Alright guys, welcome back. Today we're going to be focusing on 8.8 surface area of spheres. So this is our last actual shape that we're going to be dealing with surface area. Spheres will not have a lateral area for us, they'll just have a surface area. So this makes it a little bit simpler than the last couple episodes of videos that we've been going through. The depth of knowledge today is at level 4. We're actually going to be seeing some composite figures, making it a little bit more difficult. And what you guys will be tested on: I can find the surface area of spheres and composite figures. So these composite figures are what's really going to make this a little bit more difficult. However, some of these questions in general are a little bit difficult, a little bit challenging, but still fun. So, think of real-world examples of spheres. How would the surface area apply to a real-world context? So, just looking around the room that I'm in right now, I see basketball. Basketballs are spheres. And in case we ever need to actually create basketballs or any sort of ball, we would need the surface area of the outside material. So surface area does deal with quite a few different things. Planets are extremely important to know the surface area, how large the planet is, how much of the surface that we can inhabit, things like that. So, surface area of a sphere. Now again, we have some variables that we're going to be dealing with. Capital S is still our surface area, and R is our radius. This time our equation is pretty simplistic. Surface area is equal to 4 pi r squared. Now, you will also need to remember the volume formula for spheres. So volume is equal to 4/3 pi r cubed. So you should have that remembering back from before we left for spring break. So again, we will need to know both of these, but surface area is the one that we'll be focusing on mainly. Surface area is equal to 4 pi r squared. So here's our first problem. From the center of the Earth to the surface is 3,950 miles. Two things I want us to find is find the surface area of the Earth, and we're going to round to the nearest million miles. And then we also, for letter B, 70% of the Earth's surface is water. How much of the surface is water in miles squared? And again, we're going to round to the nearest million miles. So, if we want to do this, you got to remember that surface area is equal to 4 pi r squared. In this case, we know that from the center to the surface is 3,950 miles. So, 3,950 would actually be our variable r. So we can just go ahead and plug that right in here. And solving for s is equal to 4 pi times 3,950 squared will give us about 196 million miles squared. So that's the surface area of the Earth. Now, we know that 70% of the Earth's surface is water. How much of the surface is water in miles squared? So we're actually going to take this number. If we're taking 70%, well, if I want to find out 70% of this large number over here, I'm just going to go ahead and multiply it by 0.70. That's 70% written as a decimal. So doing that will allow us to find the surface area of the water, which turns out to be 137 million miles squared. So 137 million miles squared is the surface of water on the Earth. And whatever's left over, that, let's see, 59 million miles squared, that is how much of the Earth's surface is land then. So again, this is rounding still, so it's not exact, but it does give us a good idea of how much of the Earth is actually livable to stay on, and how much is water, which we need to survive as well. Alright, example 1. Find the surface area of the sphere. Leave the answer in terms of pi. So looking at this, we have a sphere here, and it gives us this area. It says the area is 36 pi centimeters squared. So if we look at this, this is actually what we remember as the great circle. It's the area of the circle that goes through the center of it. So I can say, oh, well, if that's the area of the circle, well, area is equal to pi r squared. Well, I know the area is 36 pi, so I can plug that in. 36 pi is equal to pi r squared. this will allow us to solve for our radius. And once we have our radius, we can actually solve for our surface area. So I divide both sides by pi. The pi's will cancel out. Left with radius squared equals 36. So as you can guess, we take the square root of both sides. We get r is equal to 6. So the radius of the circle is actually 6. Now we can go ahead and plug that into our surface area formula. Surface area is equal to 4 pi r squared. And we now know that r is 6. So this gives us surface area is equal to 4 pi times 6 squared. Well, surface area is equal to 4 pi times 36, which will bring us to our final answer of 144 pi. Now, as we can see, it says leave your answer in terms of pi. This is how it will look on the actual questions in your homework as well. And in fact, I just plug in 144 as my answer. And then the pi is implied already because they give it to us. So the surface area is 144 pi, and our radius is 6, which allowed us to solve for it. Now, you guys will be needing to piece these together as well as you go through the homework, so keep that in mind. It's not all going to be here's the radius, go ahead and solve for it. You'll have to think it through and actually solve for the radius at some points. All right, example 2. This one, we already have done one similar to it, so again, pause at any time if you need to work through it, and then I'll be going through it as well. A planet's radius is approximately 2,900 miles. So important information right here. We know the radius, so they're already telling us r. About 2/3 of the planet surface is covered by water. Enter an estimate for the land area of the planet. So again, we're looking for land. We know water. We're looking for land. Round to the nearest million, I'm guessing miles squared in this case. So let's go ahead and solve for this. So first off, we know surface area is equal to 4 pi r squared, where r is 2,900. So surface area is equal to 4 pi times 2,900 squared. Now if we enter that into our calculator, 2,900 squared will equal, let's see, that's 84,100,000. And then if I multiply that by 4, we end up with 106 million miles squared. Now, again, we're looking for land. We have water. So if 2/3 of the surface is water, that means that 1/3 is land. Well, if I multiply our surface area that we just found for the planet by 1/3, we'll find out that we have about 35 million miles squared of land. So again, I'm just multiplying by however much land there is. If 2/3 is water, that must mean that 1/3 is land. Example 3. A globe has a volume of 300 inches cubed. What is the surface area of the globe? So, we know the volume. Volume is equal to 300 inches cubed. We also know that volume of a sphere, or a globe in this case, a globe is a sphere, is volume is equal to 4/3 pi r cubed. Now don't forget, if we're cubing something, if we're going to take the cube root at the end here, in your TI 84s, if you hit the math button and you go down, it should be number 4 right here. It says cubed root, cube square root. So keep that in mind. So from here, we're going to go ahead and solve this equation right over here. I multiply by the reciprocal on both sides of 4/3, which would be 3/4. And of course, the 3 and the 3 cancel out, the 4 and the 4 cancel out. I'm left with pi r cubed is equal to 300 times 3/4 will give me 225. Now again, we're leaving our answer in terms of pi, so we want to keep that in mind, but we'll probably need to solve for it here. So from here, I'm going to take the cube, or I'll go ahead and divide both sides by pi. And then I'll take the cube root. So we end up with r cubed is about 71.6. And then solving for r by taking the cube root of both sides. So again, we take the cube root. Very important. We'll only do that if we're dealing with volume here. We don't typically do this with surface area. Now I'll give us r is about 4.15. Now from here I can go ahead and plug that back in to our surface area equation. Surface area is equal to 4 pi r squared, which will give us surface area is equal to 4 pi times our radius. Again, that's 4.15, so 4.15 squared. If I square if I square this and multiply it by 4, we end up with our answer being about 69 pi inches squared. So again, for my answer, I just plug in 69, and then the pi inches squared is already implied. All right, find the surface area of a hemisphere. So this is a bit different. We're going to be doing the same type of thing that we were using to solve for the surface area of a sphere, but there's a little bit extra there. So if we recall, the surface area of a sphere is 4 pi r squared. However, a hemisphere is half a sphere. So I'm actually going to take this and I'm going to divide it by 2, which gives us surface area is equal to 2 pi r squared. And then from here, we also now have a base. So this base is just a circle. So it'll be plus our base plus pi r squared. Now if you can imagine, this 2 pi r squared is actually our lateral area. Meanwhile, the pi r squared is the area of our base. So this is how we'll find the surface area of this hemisphere. So let's go ahead and plug in 8 for our radius. Radius is 8, so surface area is equal to 2 pi times 8 squared plus pi times 8 squared. Let's see, surface area is equal to, this 8 squared will give us 64 times 2 will give us 128 pi plus 64 pi. Combining these together, surface area is equal to, well, let's see, 128 plus 64 will give us 192 pi. And then units squared, because again, we're taking the area is in 2 dimensions, so that's why our units will still be squared. And here it is once again. Again, this is our base, and then this is the actual area of a sphere, cutting it in half. All right, let's go ahead and move on. Composite figures, we're almost near the end, but this is where it gets tricky. With surface area, it's only the area that's facing the outside. Very important that it's only the area facing the outside. So think hard when determining what you should use to find the surface area. These ones are difficult and a little tricky, but remember, it's only what's facing the outside of our shape. It's not what's covered up. So, find the surface area of the composite figure below. Go ahead and take a minute, try this one out on your own, and pause the video if you need to. All right, so we have 2 different areas that we're finding here. We're finding the area of this prism, and we're also finding the area of this hemisphere on top. Now, the tricky part is realizing that this area, this circular base, is not actually shown. So we actually need to take this out of our final surface area. So for our prism, surface area of a prism, well, if we remember, that's perimeter times height plus 2 times the area of our base. Meanwhile, the surface area of the hemisphere is equal to 2 pi r squared, as we just found out. And lastly, we need to get rid of this area for the circle. So the area of the circle is equal to pi r squared. All right, so the perimeter of our rectangular prism, well, if it's a rectangle, I know that opposite sides will be congruent. And so the perimeter is 7 plus 7 plus 10 plus 10. Well, that'll give us 34 times the height of our prism, which is 4, plus 2 times the area of our base. So the area of our base would be 10 times 7, or 70. Let's see, this will give us 16. 4 times 3 will give us 12, 136, plus 2 times 70 will be 140, which gives us 276 centimeters squared. Onto our hemisphere. Our hemisphere, well, if we look at it, our radius is 3, so I can just plug that in. 2 pi times 3 squared. This will give me 2 pi times 9, which is equal to 18 pi centimeters squared. And lastly, the area of our circle. Well, the area of our circle, if our radius is still 3, is just pi times 3 squared, or 9 pi. From here, we're just going to go ahead and add these all together. Well, not all of them. We're going to add the surface areas and take out the area of our circle. So 276 plus 18 pi minus 9 pi. Because again, we're taking out this area here. We don't want this area involved. It's not showing its face to the surface, so it's not part of our surface area. Well, this will just give us 276 plus 9 pi, which turns into our final answer being about 304.3 centimeters squared. So that's our final answer on this composite figure. Again, the tricky part is just realizing this circle is not facing the surface, so therefore it's not part of our surface area. All right. So the last homework in Unit 8, we are going to be covering density still as well, but this is the last on surface area. That will be not on my HRW. I'm actually moving all these to Schoology as fast as I can. So it should be up on Schoology for you guys. It'll be under the 8.8 homework, so keep that in mind. If you guys have any questions, please let me know. Other than that, thank you guys so much for listening. If you guys need anything, again, just please feel free to email me. Have a good one. Be safe.